Okay, guys. Post the video epiphanies. Unfortunately, in my brain, when it locked up, I needed to kind of finalize some pieces. Oops. So this right here comes into play. Remember how I talked about this was super important? So is this right here. Remember, it converges when r, the absolute value of r, is less than 1. It diverges if it's greater than 1, right? So we need to tackle this in a little different light. That's where the center comes from. So now, if I go back down here and I ended up kind of locking up right here, here it is again. Just want to throw that to you. X minus a, the absolute value of x minus a, because this is when it's centered. Let me go back up here. Sorry, guys. This is when it's centered at 0, no problem, right? It's right at 0. X minus a, r minus 0. Okay. Now, if we go back down to where we were at and we have x minus a, this is what we're dealing with. And that has to be less than or equal to r. So the absolute value of that gives us our center piece, right? And it converges to that specific spot. Okay. So that's what we're talking about, the convergence. What I was talking about, the equations like this. uh, this here is going to be the main piece that we talked about on the graph. Now I locked up right here. I just, when you lock up and your brain just freezes and then you're done. Well, I was at that point. I don't know why I was working backwards here. This is just the derivative right here, guys. So I got done and I was like, what was I trying to explain? I don't even know. Uh, this is just a constant, right? I mean, n is just some number, so that's no big deal. So that's just a constant. That's why it doesn't change. So how do we take the integral of this? Well, we're going to add 1 and divide. Add 1 and divide. That's how I got that there. I don't know why I locked up earlier. So that's how they came up with that. It has nothing to do with this over here. I was kind of totally frozen in my tracks right there. So we're integrating the left. I mean, the left. So I got to integrate the right. I integrated everything here and I could totally explain it. But mine went blank when I just need to integrate that. Okay. So don't get scared by all this like I just did. Just remember that this is just a constant. So it's just going to travel down here. And that this is just a typical function, and we're going to add 1 like it was a number, and we're going to divide by that number. So this is where we ended up after we integrate it and evaluate it from 0 to x. So I wanted to kind of go through that piece there, okay? So then when we get to here, uh, and it'll be a little more important as we get going, we would set our values equal to our absolute values less than or equal to r, and then we'd end up here. We'd end up getting this constant here. So we'd get our value. So we'd take the absolute value of the natural log of 1 plus x is less than or equal to r, right? That's what we'd end up with. So that's kind of the idea behind it. And then we would, not r is going to be 1 because, oops, this is going to be 1. And then we would get our piece, our interval that it's centered on. So we'd get our interval that this would be centered on here. And so what that going to be, we take the e to the both sides. So the first one's going to be the natural log of 1 plus x uh, to the 1, and we do the e to both sides. That'll cancel. So x is going to be less than e to the first minus 1. That's one of the intervals, right? And then the other one would be the negative natural log of 1 plus x, which is less than 1. And then we'd end up dividing by 1, which would give us the natural log of 1 plus x is greater than negative 1. And then we both sides. And so we're going to get x is greater than e to the negative 1 minus 1. And then we'd set that up as an interval there. And that's kind of that would be our interval between which this series mimics. So this series would mimic that in between those 2 points. This, I know I'm going to have to explain a little bit more, but that was just the epiphany afterwards. Sorry, guys, but we'll make sure this works.